Hello and welcome to GED Live at PALS. This is the first GED Science practice test in 2021 and this is part 1. If this video is helpful for you, please ring the bell on our YouTube channel and subscribe to bring you more of these helpful videos to prepare for your tests. Let's get directly started with the first question. So question 1 of our test. The table below lists the normal ranges of various chemicals found in the human blood. We have cholesterol, which is about 125 to 200 milligram per deciliter. There is HDL cholesterol and LDL cholesterol, which are respectively 40 milligram per deciliter and under 130 gram per deciliter, and they are triglycerides, which are under 150 milligram per deciliter. Which of the following statements is accurate based on the table above? So let's have a look at the 4 answers. A total cholesterol level of 150 is considered normal. A triglyceride level of 180 is considered normal. An LDL cholesterol level of 110 is considered above normal. A triglyceride level of 100 is considered abnormal. So the correct answer here, this question shouldn't be too difficult, is A. Total cholesterol level of 150 is considered normal. Answer A. Why is that? Because if we look at the normal range of total cholesterol, it's 125 to 200 and 150 is in that range. Now if we look at the other answers, we can exclude all of them. Triglyceride level of 180 is considered normal. No, it's not. Under 150 is considered normal. 180 is above. LDL of 110 is considered above normal. That is not correct. Above normal would be above 130, not 110. And triglyceride level of 100 is considered abnormal, which means not normal. And we can see that for the triglycerides under 150 is normal. So it's not answer D as well. Okay, let's move on to the second question. Cardiac output is the amount of blood a human heart pumps out per minute. Increases in heart rate, blood pressure, and cardiac muscle strength all lead to higher cardiac output. Below is a graph that shows the effects of blood pressure on cardiac output. Which of the following conclusions is best supported by the graph? So before we have a look at our possible answers, let's quickly have a look at the graph and what it shows. We can see that with increasing blood pressure, which is on the x-axis, the cardiac output will go up. And the graph again shows us cardiac output based on blood pressure. So in general, on graphs, whatever is on the x-axis will affect what happens on the y-axis. So x affects y, or changes in x will cause changes in y. So an increase in blood pressure will cause the cardiac output to go up. So let's have a look at the possible answers. As blood pressure increases, cardiac output decreases. As blood pressure increases, cardiac output increases. Cardiac output is measured in milligram Hg. Cardiac output increases and decreases irregularly as blood pressure changes. So here the answer shouldn't be too difficult as well. We see that blood pressure increases as cardiac output increases. So the correct answer is B. Here we have a linear relationship. The cardiac output is not varying. It is just linearly going up as blood pressure is going up. Okay, let's move on to the next question. Question 3. So this paragraph and food web will be related to the next two questions, 3 and 4. A food web is a diagram that shows which organisms feed on which other organisms in a community. The arrows point from the food source to the consumer. Some animals are herbivores, meaning that they eat only plants, while some others are carnivores, meaning that they eat only other animals. Still others are omnivores, meaning that they eat both plants and animals. Below is a food web for a grassland ecosystem. So we see grass and plants at the bottom of the food web, and the arrows pointing to a couple of organisms, mice, insects and birds, which then point to others again. At the top of the food web we have hawks. So let's have a look at question 3. Which organisms in the food web are carnivores only? Hawks only, snakes only, both snakes and hawks, snakes and insects. So let's check these 3, hawks, snakes and insects. We can see that insects, they feed on grass and plants, and what else do they eat? They eat other insects, that's it. Other arrows that are connected to insects, we have one arrow that goes towards the mice. That means that mice eat insects, but not the other way around. So insects eat grass and plants, and insects eat other insects. Then we have the snakes. Snakes eat only mice, and hawks eat snakes, mice and birds. So which of these 3 organisms, hawks, snakes and insects, are carnivores only? Again, one more time, what are carnivores? This was mentioned in the text above. Carnivores are organisms that eat only other animals. So we can see that the insects, they feed on grass and plants, so we can exclude the insects from our answer, so it's definitely not answer D. And we can see that snakes eat mice, mice are animals, and hawks eat snakes, mice and birds, and these 3 are animals as well. So the correct answer here is answer C, snakes and hawks. Okay, let's move on to the next question. So, again, this is a question based on the previous information. Hawks consume rabbits as well as the other animals listed in the food web. If rabbits are herbivores, which of the following food webs accurately includes rabbits in the grassland ecosystem? So let's have a quick look at the previous picture. Here's our food web, and which is the correct new food web, including rabbits. Again, the information that we get is that hawks consume rabbits, and that rabbits are herbivores, which means they only eat plants. That means we need an arrow that goes from the grass to the rabbits, and an arrow that goes from the rabbits to the hawks. And we can see that we can exclude answer A. We have an additional arrow going from mice to rabbits, and there is an arrow going from hawks to rabbits, which is the wrong way around. Here, that's wrong as well. There's no arrow supposed to be going from birds to rabbits. Same here, insects to, where are the rabbits? Here. That is wrong as well. rabbits need to be connected to plants and not to insects, so the correct answer here must be answer B. We have an arrow going from grass and plants to rabbits. They are herbivores and they are eaten by hawks only, according to the information in the text above. All right, let's move on to the next question. Whether a substance is classified as acidic, basic, or neutral is determined by its pH. A pH below 7 is acidic, a pH of 7 is neutral, and a pH above is basic. Below is a table of common substances and their pH values. Lemon juice 2, water 7, vinegar 2.2, baking soda 8.3. Based on the information above, what percent of the substances in the table are basic? You may use a calculator. I don't think we need a calculator for that one. We can see that the only substance that is above 7, again, pH above 7, that means it's basic, and we are looking for basic substances. The only substance that has a pH above 7 is this one, baking soda solution. That means we have 1 out of 4 substances that is basic. As a decimal, this is 0.25, and to find the percentage we times this by 100, which gives us 25%. All right, next question. Question 6. A geode is a rock that appears dull on the outside but is filled with crystals inside. Many scientists theorize that some round geodes are formed when lava bubbles as it cools after a volcanic eruption. Minerals and water seep into the bubbles, and after the water evaporates, the minerals form crystals. Which of the following best supports the theory discussed above? Round geodes generally contain fewer crystals than do geodes of other shapes. Some geodes have been discovered in areas where there are no volcanoes. The water and minerals that seep into geodes cool quickly after entering air bubbles inside the geodes. The minerals found in round geodes are also typically present in volcano lava. This is probably a bit more difficult question here. Let's have a look at the possible answers. Round geodes generally contain fewer crystals than do geodes of other shapes. There is no information whatsoever about geodes of different shapes in the text above, so we cannot find answer A as the correct answer here, because we just don't get the information about it. So the text or the answer A is not supported by the theory above at all. Some geodes have been discovered in areas where there are no volcanoes. This statement would actually do the opposite. It would not support our theory above. It would more reject our theory above, because the theory above says that geodes are formed by lava bubbles as they cool down. So if there were geodes found in areas that are not related to volcanic eruptions, that would refute this theory or hypothesis, not support it. So we can exclude answer B as well. Answer C, the water and minerals that seep into geodes cool quickly after entering air bubbles inside the geodes. If we look at the last sentence here, it says minerals and water seep into the bubbles, and after the water evaporates, the minerals form crystals. So as well, if C was true and the water was cooling quickly, that would mean that the water would probably not evaporate, because cold water evaporates much slower than hot water. and the water would probably stay within the geode. So instead of finding crystals when opening the geode rock, he would probably find a load of water inside. So answer C does not support our theory above. Answer D, let's see if that does support, I hope. The minerals found in round geodes are also typically present in volcano lava. Yeah, well, that makes sense. For sure, if these geodes are formed during volcanic eruptions by lava bubbles and water with dissolved minerals inside these bubbles, water evaporates, leaving behind mineral crystals. For sure, these minerals must have been in the lava beforehand for them to be present in the geodes after. So that statement definitely supports the theory above. So the correct answer here is D. Question 7. A scientist wishes to determine whether using compost and nitrogen-rich fertilizer together will be more effective than using either alone. She hypothesizes that if she uses a combination of compost and nitrogen-rich fertilizer, then the plants that she grows will be taller and will grow more abundantly than they would if she used either independently. To test her hypothesis, the scientist designs an experiment using groups of plants, with each group receiving different treatment, and with each group monitored and measured. What is the minimum number of groups of plants that the experiment will require? So let's take a minute to think about that. So, as the text says above, the scientist, she wants to test whether compost and nitrogen-rich fertilizer together will be more effective than using either alone. So that means in our experiment we need to test both of them combined to see if that's going to be the best one. And we need definitely to check whether one of them alone, compost on its own or nitrogen-rich fertilizer on its own, will yield a better result. So these are 3 groups for now. So we have, let's call it our group A, compost plus nitrogen fertilizer. Group B, only compost. Group C, only nitrogen. Well, is there another group missing that we should include in this experiment? The answer is yes. We need one last group. This last group is our control group. Every experiment needs a control group. The control group will give us the baseline. It will tell us how plants grow normally without any fertilizer, just receiving the normal treatment, so that we can compare the other 3 groups to the control group. And that means we need 4 groups in our experiment here. All right, let's move on to the next question. Question 8 is based on the passage below. Hereditary traits are encoded in genes, which in turn are located on chromosomes. Chromosomes come in pairs, and the pair of genes associated with a particular feature determines the characteristics of that trait. Often there are several varieties of genes associated with a given trait. A gene is expressed when it is pure, meaning that it is expressed when both genes in a pair are alike. A hybrid pattern occurs when 2 genes in a pair are different, and in cases of incomplete dominance, the 2 traits will be blended together to make a new trait. Flower color in carnations follow an incomplete dominance pattern. When both genes in a pair are associated with the color red, then the plant produces red flowers. When both genes in a pair are associated with the color yellow, the plant will produce yellow flowers. When a plant is a hybrid and has one gene associated with the color red and another associated with the color yellow, then the two traits blend and produce orange flowers. Below is a Punnett square showing the results when a carnation with yellow flowers and a carnation with red flowers are crossed to produce offspring. Punnett squares predict the likelihood of specific gene combinations occurring in the offspring depending on the gene combinations in the parents. So we can see we put the egg cell of the female parent on top and the sperm cell of the male parent on the side. Other way around works as well, we just can't mix them up. And we see here the likelihood of the offspring. Big C stands for color, and we can see the R and the Y associated here. CR for red flower color, CY for yellow flower color. And we can see that in this case, all 4 offspring, or 4 possible combinations for flower color are the same. That means that all offspring will be orange, and we can see the correct answer must be this. Let's look at the question. What color are the flowers of the offspring shown in the Punnett square? They are all orange. Again, why orange? Because we have incomplete dominance here, and in incomplete dominance patterns, 2 traits will blend together to make a new trait. Red and yellow will blend to give orange. Okay, question 9. It's based on the following information and diagram. Water is constantly being naturally recycled on Earth. Below is a picture of the water cycle, which depicts the natural processes that affect the flow of water. We can see that we have the oceans. From the oceans, water is evaporating, forming clouds over the oceans, which eventually rain again over the oceans, and we have a small cycle here. Eventually, clouds that form over the oceans by evaporation of ocean water are blown over land by wind, so water can fall on land as well in the form of rain, seep into the soil or into rivers or lakes, and run off in the ocean again. We will have evaporation from lakes and rivers as well, forming clouds over land. Another form of water getting into the atmosphere is by transpiration, which is basically the evaporation of water at the leaves of plants. Based on the figure, which of the following processes delivers water to clouds? Okay, we can see how does water get into the atmosphere and form clouds. Let's have a look which arrows go up from a water source to the clouds. We can see that we have evaporation here. We can see that there is transpiration here, and we can see there is evaporation again here from lakes and from the oceans. So, based on the figure, which of the following processes delivers water to clouds? Evaporation only? Nope, that is not true. Evaporation and transpiration? Yes, that must be correct. Look, see, transpiration only, no evaporation and precipitation. That is wrong. Precipitation, this is another term for rain. Precipitation is raining. Okay. Question 10. The balanced equation below represents the oxidation process of propane. Which of the following describes the reaction shown above? Oxygen reacts with propane to create carbon dioxide and water. Oxygen and propane react to create water. Oxygen is converted into carbon dioxide. Propane is converted into water. So, what do we have here? We can see the reaction or the equation, the symbol equation up here. In terms of a word equation, the first substance that we see here, C3H8, is propane, which will react with oxygen. Plus oxygen means it reacts with oxygen. Then we have the arrow here, which means it reacts to form. So propane and oxygen react to form carbon dioxide, CO2, and water, H2O. That means that the first answer, answer A, oxygen reacts with propane, or the other way around, propane reacts with oxygen, that doesn't matter, reacts to create carbon dioxide and water. So answer A is correct. Question 11. Below is a table showing the percentage of total blood volume for several components of human blood. We have dissolved gases, nutrients, red blood cells, water, and white blood cells, with the respective percentages that we can see here. What percentage of human blood is not made up of cells? Okay, what are cells here? We can see we have red blood cells and we have white blood cells. So first of all, let's see if all the percentages add up to 100%. I hope they do. So what do we have to do? 43 plus 51 will be 94, plus 1 is 95, plus 3 plus 2 is 100. So they do add up to 90%. Then let's take out the cells. They add up to 100%, sorry. Let's take out the cell parts, red blood cells and white blood cells. The rest, dissolved gases, nutrients and water, are not cells. So let's check again. What's the question? What percentage of human blood is not made up of cells? So let's subtract the cells. 43 plus 2 is 45. So we have to calculate 100% minus 45%, and that will give us 55%. And that's our answer, 55%. Okay, next question. An enzyme speeds up a chemical reaction by interacting with an initial substance and making it easier for that substance to form a product. In most cases, an enzyme can interact with only one molecule of the initial substance at a time. The graph below shows the results of an experiment that measured the rate of product formation as the concentration of an initial substance was increased. A limited amount of enzyme was present during the experiment. Which of the following best describes the results shown in the graph? As the concentration of initial substance increased, the rate of product formation. Okay, so let's quickly summarize these 2-3 paragraphs here. So what this paragraph basically tells us, we start with an initial substance. And this initial substance will basically undergo a reaction to form a product or products. And this reaction is controlled and sped up by enzymes. By an enzyme. It tells us as well that in most cases an enzyme can interact with only one molecule of the initial substance at a time. So if there is an enzyme and we have a substance bonded to it, there is not another substance that can bond to the enzyme at the same time. So an enzyme can only do one substance at a time. So let's read the question again. Which of the following best describes the results shown in the graph? As the concentration of the initial substance increased, the rate of product formation. Okay, quick look at the graph as well. Enzymes and product formation. So again, we have here our x-axis and our y-axis, and again, to clarify, whatever when we change something on the x-axis, this will affect the y-axis, or this will cause the changes that we see on the y-axis. So we can see that when we increase, so we have a limited amount of enzyme, that's important as well. Amount of enzyme is limited, there's only a certain amount of enzyme present, and now we increase the concentration, the amount per volume of the initial substance. So we increase the amount of initial substance present, and we can see increasing the initial substance will as well increase the rate at which our products form, until we get to a certain point round about here, where it starts to slow down, and then our line basically becomes flat. So what happens on this graph? The rate of product formation increased continually, initially increased and then became constant, increased and then decreased, or just remained constant all the time. Now, as we just said, first it increased and then it slowed down until nothing happened anymore. It didn't increase, it didn't decrease. That means in this question, answer B is correct. Initially it increased and then it became constant. Doesn't go down, doesn't go up, constant. All right, next question. Question 13. Plants and carbon dioxide use carbon dioxide to make food, and then that food is consumed by animals and eventually returns to the soil or the atmosphere. The diagram below shows the carbon cycle. Let's have a quick look at the carbon cycle. What happens here? We get some information. Let's start with carbon dioxide in the atmosphere. That carbon dioxide in the atmosphere in this diagram is absorbed by plants by the process of photosynthesis. Plants use their own food in respiration to release the energy from it again for different cellular processes or growing bigger, releasing carbon dioxide to the atmosphere again. The food produced by photosynthesis can as well get into animals that eat plants, or carbon dioxide can get into the soil by roots respiring. Plants eventually die without being eaten, so they become dead organisms which get decomposed and become waste organic matter, dead organic matter. Decomposers decompose them, so they respire and carbon dioxide goes back into the atmosphere as well. Animals that ate plants as food eventually produce waste products or die. Again, will be respired, broken down by decomposers, carbon dioxide goes back into the atmosphere, or animals themselves do respiration and break the food down into releasing carbon dioxide as a waste product, which goes into the atmosphere. So let's have a look at the question. Which of the following describes a process shown in the diagram? Plants absorb carbon dioxide from the atmosphere. That is correct so far, and transfer some of that carbon dioxide to animals in the form of food. That sounds good to me. After which animals will release waste products and transfer some of that carbon dioxide to the soil. Alright, doesn't sound too bad. Let's have a look at the other options. Animals absorb carbon dioxide from the atmosphere. Okay, we can immediately exclude answer B. Animals do not absorb carbon dioxide from the atmosphere, as we can see. Let's look at C. Plants absorb carbon dioxide from the soil through respiration. No, that is not correct. They do not absorb carbon dioxide from the soil, otherwise the error would be the other way around. So let's cross out C as well. And D, plants absorb carbon dioxide from the soil through root respiration. Again, we can exclude that immediately, so we don't even need to read the complete answers here. We can immediately see from the very first statement in B, C, and D that the answers must be wrong. So the correct answer is A. Next question. In most environments, there are limited numbers of nutrients. As a result, living organisms must compete for food and resources. The graph below shows the results of two experiments, one in which an amoeba was cultured alone and one in which it was cultured with a mixture of other single-celled organisms. The same nutrients were provided to each culture. An amoeba is a single-celled organism as well, to clarify that. What do we see in the graph? We can see the amoeba population. So with the y-axis going up, the population of amoebas goes up as well, and on the x-axis we have time. So with increasing time, we can see on both graphs that the amoeba population is increasing. However, where we have a mixed culture, amoebas with other single-celled organisms, amoebas increase and then it flattens relatively quickly at a population size of about 100, a little bit above 100 probably. Whereas when we have amoebas alone, it goes up to almost 5, a population size of 500, where it flattens. So which of the following conclusions can be drawn from the graph above? This species of amoeba is more likely to thrive if cultured in a mixed culture than if cultured alone. What does thrive mean? It does very well in a mixed culture compared to when growing alone, or we can exclude that answer because, as we can see, population size in a mixed culture is lower than when cultured alone. So it is not answer A. This species of amoeba is more likely to reproduce rapidly if cultured alone than if cultured in a mixed culture. That we can exclude as well. We can see that the line of the culture where we had only amoebas is much steeper, which means it reproduces much quicker than in the mixed culture. The population of the species of amoeba will continue to increase indefinitely if the amoebas are cultured alone. That is not true as well. Increasing indefinitely would mean that our graph just would continue to rise. It doesn't do that. It starts to flatten, and which means that our growth of the amoebas stops. And that means we can exclude C as well. Let's check if D is correct. If cultured in a mixed culture, the species of amoeba will initially increase in its population size, but will eventually die out. Well, eventually means, yeah, so I think that is the best answer that's supported, because we can see that it goes up and then it starts to go down, and we don't know what will happen further, but eventually it will further decrease and die out. So the best possible answer from these three options is D. Okay, next question. Scientists use the following formula to calculate the force of gravity that two objects exert on each other. In the equation, F equals G times m times big M times small m divided by r squared. We can see what the different letters mean. F is the force of gravity, G is a constant value, the gravitational field strength, m is the mass of one of the objects, small m is the mass of the second object, r is the distance between the center of the two objects. If an object object with a given mass, m is replaced by an object of half its mass. Which of the following will increase the force of gravity? Replaced, let's have a look here. A, increasing mass big M and doubling the distance between the two objects, reducing mass big M and doubling the distance between the two objects, reducing mass M and halving the distance between the objects, increasing mass M and halving the distance between the two objects. Okay, so what will give us in general, the question is what will give us a bigger M? If an object with mass M is replaced by an object of half its mass. So first of all, decreasing anything in the top bit of the equation will lead to a decrease in the force of gravity. Whereas if we increase the denominator, that would lead to a decrease of F as well. So what we want to get our largest increase in F is we want to increase whatever we have up here, and we want to decrease whatever we have in the denominator to get our biggest possible force of gravity. And the only answer that does this is increasing mass M. Again, why that? Because mass M is up here. Making that bigger will give us a bigger F. And halving the distance between the two objects, again, R is related to the distance between the centers of the two objects. So if we halve R, that means it becomes smaller. Making the denominator smaller will give us a bigger F. So that will cause F to go up if we increase this and decrease the denominator. So the correct answer is D. Question 16. The table below shows an analysis of the composition of soil taken from a canyon in the desert. So we have different materials. You can have a read through these on your own. And their percent composition. The question is, what is the median of the numbers listed in the table above? So you need to know for the GED test what the median is. Not only the median, you need to know what the mean is, what the median is, what the mode is, and what range is. So let's write these down. No? We need to know mean or average and how to find it. We need to know median, we need to know mode, and we need to know range. So mean average is found by adding all the numbers up and then dividing by the total amount of numbers that we have added up. So if we would add all of them up, and then we would have to divide by, how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would add all of them up, divide by 10, that would give us the mean or the average. The mode is the most common number, so we check if there are any doubles or triples of numbers, and the number that occurs most frequently is our mode. So in this set of numbers we can see that we have the number 2 twice, so the number 2 in this case would be our mode. Range is the difference between the largest and the smallest number, so in this case it would be 25 minus 2. The range would be 23 in our case, so we can write that down. 23 is the range, mode would be 2. I'm not going to calculate the mean now. Again, adding all of these up, dividing by 10. This probably adds up to 100 since it's percent composition, so the mean percentage in this case would be 10 because we have 10 values. It doesn't really make sense to calculate the mean here. The median, to answer our question, is the middle value. So how do we find the middle value? If we have a set of numbers, we should arrange the set of numbers in order first. So that's already done here for us, which is quite nice. We start with the smallest number and we can see the numbers are increasing, so it's already in order for us. Now we want to find the number in the middle. So we can check. We have again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Now that's a problem. If we have an even number, there is no direct middle. The middle is, we have 5 values, 1, 2, 3, 4, 5. We're ending up at 8, and then we have 5 numbers again. That means the middle is somewhere between 8 and 11. And if we have an even number of values and we have to find the median, then we take these two numbers in the middle and we do the same as we do for the mean. We add them up and we divide them by 2. So to find the median here, we add 8 plus 11. This is 19, and we divide 19 by 2, and that is 9.5. So the median in this set of numbers is 9.5. And let's look at questions 17 and 18, which are related to the graph below. The graph below shows the amount of rainfall during the spring and summer months in the city of Mayfair. Amount of rainfall in spring and summer, March, April, May, June, July, August, and amount of rainfall, average monthly rainfall in millimeters. Between which 2 months was the increase in average monthly rainfall the greatest? Well, we can immediately see that we have to check from month to month. Where is the difference the greatest? And it is obviously March and April. No, this difference is the greatest. So March and April, answer A is the correct answer here. For 18, what was the mode of rainfall for the month shown above? Okay, we just discussed what the mode is. The mode is the most reoccurring value in our data set. We can see that we have 2 months that have the same rainfall, June and July, so that's going to be our mode, and I think they are 40. So answer, let's double check if that really is 40. 40 is here, and yes, it is 40. So answer A is the correct answer. 40 is occurring twice, all the other numbers are occurring only once. Alright, that's part 1 of the new GED Science Practice Test 2021. This was GED Live at PALS. If this video was helpful for you, please ring the bell and like our YouTube channel, subscribe, and come back for part 2 of the practice test. Hope to see you next time. Have a good day.